Alright, Tom's teacher's given him two light bulbs, A and B, here they are. They've got a resistance of 2 ohms and two resistors, 0.5, 0.5 and a 24 volt battery, and he connects it up like shown. The first question is asking us to find the voltage across each of the bulbs, A and B. What I'm going to do for this circuit is I'm just going to redraw it. Might make it a little bit easier if I redraw it. How to visualise it. There's my resistor. And then we've got a junction here, so what I'm going to do is I'm going to draw that junction like that. We've got our light bulb A, and we've got a light bulb B. And then we've got our last resistor here. So this circuit I've redrawn it exactly the same. I've got my first resistor, then I've got a parallel. Now when I draw it like that it's much easier to see it's a parallel, but it's exactly the same circuit. The parallel finishes here, and that's where it finishes here, and it goes through this guy here, 0.5. 0.5, 2 ohms, 2 ohms, 0.5. Indicate the voltage across each of the bulbs. Well, the 20 volts used up total. The way I'm going to go through this one is I'm going to say, well, I've got the resistance in each of the bulbs, 2 ohms, 2 ohms. If I can calculate the voltage in A by saying, if I know the current in A, I can times it by the resistance of A. And that'll give me my voltage in A. So how do I find the current? Well, I'm going to work backwards. I'm going to find the total current. Total current. What is the total current? To do that, I know the total current. I can just use my V equals the main formula here, V equals IR, rearranged, I equals V over R. Because I'm finding total current, I need the total voltage and the total resistance. The voltage is 24, that's really easy. The total resistance is a little bit harder. We've got to work out the resistance of this first. And let's do it over here. It's in parallel, so 1 over RT is 1 over 2 ohms, 2 plus 1 over 2. 1 half plus 1 half equals 2 halves, which equals 1. Half plus half equals 1. Total. To find the total resistance in the parallel, now I've got to flip it, so that equals 1 ohm. And that 1 ohm is just those two together. We've got a 0.5 and a 0.5, so 1 plus a half is 2 ohms. That's the total resistance in the whole circuit. And 24 divided by 2 is 12 amps. So 12 amps comes along here, out. Well, it actually, sorry, it goes from positive to negative, it goes this way. 12 amps goes through here, 12 amps goes along here, then 12 amps splits up. Because A and B are the same size, 12 amps splits up evenly. 6 amps on each side. So now I've got enough to do my calculation here. The voltage in A is equal to the current in A times the resistance of A. I've just worked out the current in A is 6 amps. Resistance of A hasn't changed, it's 2. It's 12 volts. I could do the same for B, but again 6 amps, 2 ohms, 6 times 2 is 12 as well. It turns out for this next question, what's the current drawn from the 24 volt battery? We've already answered that. We've already answered it here. We're just going to put some working down now to make sure we've got it all down, get the full marks. So we said the I total was equal to the V total over R total. But R total equals, what have we found? We found it was equal to a half plus 1, which equals to 2 ohms. So it equals 24 divided by 2 equals 12.